Okay, now it's about robust header compression. This is also a standard feature which is usually enabled by default. You just need to check or make an audit for your network, but usually this is being enabled. But let's just explain how this feature is working and what kind of improvement we can get whenever we enable this feature, and how also to verify from the drive test whether the feature is being enabled or supported by the users or not. Okay, as if you can recall, robust header compression in general, what it do, as mentioned by the name, as stated by the name, it just make a header compression. So the main advantage of this feature is trying to reduce or make a header compression to reduce in general the packet size. And if you reduce the packet size, you will be able even to improve your uplink performance or block error rate, because you will have, for example, assume you're using 20 resource blocks on uplink location, but after the packet reduction, size reduction, you need also to only to use 10 resource blocks instead of 20. So you'll have even more power per resource element. So this will be reflected in you having a better uplink coverage and even less block error rate or much better block error rate. So the main advantage here, you are improving the capacity in general because you are doing a reduction for the packet size, and you're improving your uplink performance, especially for block error rate and coverage as well. So this is actually the general idea in the left here. If you look into the left as a general high level concept, you see, for example, this is the compressor and this is the decompressor, even sender or receiver. So in the compressor, what's happening in the first, when the packet is being transmitted, as you can see, you have the data or the payload, and you have some here additional header, which is IP header, UDP header, and RTP header. And usually the IP header is having very high size. So actually, the main idea that I would like to confirm that this is happening at the BDCB layer. This is the robust header compression is happening at the BDCB layer. So at the BDCB layer, you will be having a compressor. The compressor will establish the context. I will explain this one in more details. Then it will be transmitted. The compressor and the compressor will have an establishment of the context through sending the first packet in general as it is, without any compression. The first packet will be sent from the compressor to the decompressor or sender to receiver. Without the first packet will send without any compressor, but both of them will establish a context out of this packet. For example, this packet have a specific sequence. If you can see here, this packet, for example, is 21XX01. So we found that there is some static numbers within the packets. This is all the packets. It's 21XX01, 21XX02, and till 06. And that the compressor will understand that the context of this one is 21XX0. So they will establish the context, which is, as you can see, between the compressor and the compressor. The first one will be sent as it is. Then they will establish the context, which is 21X00, as highlighted here. Once the context is being established, now only the one which is out of the context will be transferred. So before you used to transfer, let's assume this one as 6 bits or 6 bytes, for example, 1, 2, 3, 4, 5, 5, 6. Now we need only the compressor need only to pass only one packet, and the decompressor, because it's having the context being established, can decode the data successfully. So in this case, usually instead of, or initially you would like to send, for example, 6, let's say bytes, multiply by 6 also, which is 6 numbers here, you will have 36. So once you establish the context, you need only to transmit 11. 11, why it's 11? Because the first one you need to transmit as it is, which is related to 6, then 7, which is the last digit, 8, 9, 10, 11. So you have 11. Then you need just the compression ratio will be around 70%, because usually you need to transmit 36, but in this case you are transmitting only 11 instead of 36. You have around 70% improvement or reduction in the packet size, and this is how it's been working. And as you can see here, usually this is what happens after the header compression. For example, here you have the larger size of the header is related to IP version 4 or IP version 6. IP version 6 even having higher packets. So usually the robust header compression will reduce it to around 1 to 3 bytes. And if I can recall it, usually IP version 4 have around 40 bytes as a size, and IP version 6 will be have around 60 bytes. So at the end, it will reduce to only 1 or 3 bytes, and this is how we get the gain. So now let's jump into how to verify first the capability of the device from the logs, and what kind of requirements, which parameters we need to check from the logs, from the capability, and how also to confirm whether it's being triggered by the InnoDB or not. Okay, if you look into this figure, this is actually the figure on the left here. This is if you look into that part under the UE capability information message, which is sent by the UE to the InnoDB. The UE is informing the Unit B about its own capability. So you need to go through under the BDCP parameters. As you mentioned, that ROC or ROHC is supported by the BDCP layer. So the user is sending something called profile 1, 2, 3, 4, 6, and so on. Actually, usually the voice for the robust header compression for the voice is about profile 1 and 2 and even 3, but those are especially 1 and 2. So you need just to check whether those being supported or not. If it's false, this means this particular user is not supporting the robust header compression, because you need support profile 1, 2, and 3 as shown here. So this is the most important from the capability point of view. So you might do some insights in the network to check, for example, how many users supporting the feature or not. Then we can, for example, raise it to the vendors to try to ask them, if some device is not supporting, to ask them to try to add the capability for the devices. And here from the Unit B side, whether during the RSU configuration when sending XI1, RSU configuration to configure XI1 data radio bearer, it will send under BDCP configuration data, again ROHC in the BDCP layer. So if it's sent not used, this means header compression is not being activated. The feature may be off, not be working. So this means it's not being or even the user not supporting. But if it's being activated, as you can see here, it will send under the same part here, BDCP layer, under the BDCP configuration. Here, for example, first the RLC, as you know that for XI1, it's usually using unacknowledged mode. And here this is the ROC configuration. So it will send profile 1 and profile 2, which is showing as true here, which is indicating that yes, robust header compression is being supported. So now we can start establishing our context.